Have you ever actually stopped to wonder how a simple, everyday word transforms into a legitimate scientific breakthrough? I mean, how did the casual things we just say to each other eventually become the literal building blocks for massive society-altering theories? It's kind of a giant puzzle, and today we are going to solve it.
Welcome to This Explainer. Today we're doing something really cool. We're tracing the exact path from the basic words we speak every single day right up to the grand theories that explain why our societies function the way they do. Let's dive in and see how human language evolves into complex sociological frameworks.
Here is our roadmap for today. First up, words, meanings, and concepts. Then, the scientific theory pipeline. Third, defining concepts in sociology. Fourth, classical sociological theories. And finally, modern and middle-range theories. All right, let's jump right into Section 1, Words, Meanings, and Concepts. Picture this. You've got 9 different lineages of the Naga people, all living in separate valleys in northeastern India. One day, they all sit down together, and someone asks for a specific item in their local dialect. The problem? Nobody else understands what they want. Eventually, everyone just opens a small packet they brought with them, and it turns out inside every single packet is salt. But because they had 9 completely different words for it, the communication just totally failed. This is a brilliant example of how absolutely vital a universally agreed-upon word is. You see the exact same thing in formal institutions, right? Like in Parliament, a piece of furniture isn't just a chair, it's the chair, and it literally represents authority. Words absolutely have to carry a shared meaning for social interaction to even be possible. So this brings us to something philosophers, especially the guys from the famous Vienna Circle, call an intersubjectivity agreement. It's a bit of a mouthful, but the idea is actually super simple. It's about consensual meaning. They argued that things are described through human activity and agreed meanings. In this sense, reality itself is a social construct. We don't just objectively see the world. We literally construct our reality through the consensual meanings of the words we use to describe it. And right there, that's the leap. Going from just a mere word to a full-blown concept. A concept is basically a word that has gained a highly technical, completely agreed-upon meaning to signify very specific properties. Think about it like this. If you tell a friend you have a fever, well, that's just a common word. But as medical science steps in, words like malaria or influenza take over. Those are concepts. They tell a physician exactly what components are interacting in your body, and that allows them to measure your temperature or your blood sugar against a universally understood baseline of what's normal versus pathological. Now, here's the thing about concepts. You can't actually physically see them. We arrive at them through a process called conceptual abstraction. We move from the specific to the general. When you say the names Somnath or Abul Kalam, those are highly specific proper nouns. But when you refer to the Speaker of the Lok Sabha or the President of India, you are abstracting. You are talking about the overarching characteristics of the role, entirely regardless of who actually holds it. This kind of abstraction is the exact bridge we absolutely need to cross over into formal scientific theory. Moving right along to Section 2, the scientific theory pipeline. Okay, let's break down this pipeline. How exactly does science build a theory? Well, it's basically a 4-step process. First, you identify the absolute smallest unit, like in chemistry, when they discovered the atom and its atomic weight. Second, you observe the interactions among these units. How do elements mix without losing weight? Third, you make conceptual statements about those interactions. And fourth, you do frequent experimentation. If your results hold up across tons of trials, your conceptual statements become theoretical propositions. Link enough of those bad boys together, and boom, you have yourself a fully formed scientific theory. But here is the catch. This pipeline looks very different depending on the field. In the natural sciences, it's highly predictable. It's much like algebra. Once you prove that a plus b squared equals a squared plus 2ab plus b squared, you can plug literally any numbers in and the formula always works. It's universally predictable, for sure, just like Newton's theory of gravity. But in the social sciences, well, we can't exactly put human societies in a test tube, right? Our experiments have to be indirect. We rely really heavily on comparative history, looking at how completely different societies and groups react in unique historical settings just to find our theoretical patterns. Which brings us to Section 3, defining concepts in sociology. So if chemistry has the atom, what does sociology have? Well, British social anthropologist Rodcliffe Brown suggested the foundational building block of human interaction is something called the dyad, which is simply a relationship involving exactly 2 people. Think of a brother and sister or a mother and son. When a dyadic relationship is repeated time and time again, it starts to acquire a pattern. And when that pattern eventually becomes an expected behavior, it forms what sociologists call a role.
There's this fantastic quote by S.F. Nadel. He famously said, "One individual is many persons." And man, doesn't that just hit the nail on the head? This is exactly where human variables show themselves to be vastly more complex than chemical elements. Think about your own day for a second. You wake up and you are a child to your parents. You go to work or school and you're a student or an employee. You come home and you're a sibling or a friend. You are one single biological individual, but socially, you are navigating multiple structured roles every single day of your life. All right, let's look at how the pros did it in Section 4, Classical Sociological Theories.
Those early sociologists, they were basically detectives. They had to build grand theories out of these constantly shifting human variables. Emil Durkheim is a perfect example of someone who applied a truly rigorous scientific methodology to human behavior. He didn't just guess. He took raw empirical data and built a grand theory around a deeply personal act, suicide. He clarified the terms. He located distinct types of suicide. Then he classified existing official data, compared the social facts, and ultimately formulated this brilliant theory that explained suicide rates not just as individual isolated tragedies, but through the varying degrees of integration and solidarity within a society. He literally proved that social facts could be studied just as rigorously as gravity.
Then you've got Max Weber, who followed a similar, super rigorous path of comparative history. Weber really wanted to understand the rise of capitalism. So what did he do? First, he defined his key concepts, the Protestant ethic and capitalism. He then looked at historical settings where both were present and places where they were totally absent. By comparing data on things like religious education across different groups, he confirmed a massive coincidence between Protestant-dominated regions and the rapid rise of capitalism. Weber showed us the immense explanatory power of comparing unique historical context to uncover the hidden rules of human economics and cultures.
Now let's fast forward a bit to Section 5, Modern and Middle-Range Theories. Think of sociological thought like a giant spectrum. Way over on one end, you have these grand theories. Think of Talcott Parsons' general theory of action, which basically tried to integrate economics, psychology, and sociology into one massive, all-encompassing system to just explain the whole shebang. On the completely opposite end, you have basic empirical descriptions, just raw tables of data with zero explanation. But right in the middle, the Goldilocks zone, you have Robert Merton's middle-range theories. Merton realized that grand theories were often way too broad, and raw data was way too narrow, so he developed middle-range theories to act as practical, heuristic guides for actual field studies. They were just the perfect size to be highly useful for real-world research. This is where you really see Merton's genius shine. He took these older concepts and he completely modernized them. Instead of just looking at a societal structure and saying, oh, it has a function, Merton insisted on looking at the function, the dysfunction, and the non-function, all to find the overall balance of consequences. For example, he looked at the role set, that complex web of relationships an individual has just by occupying a single status. He analyzed how sometimes societal goals actually clash with the available means to achieve them, which ends up causing societal strain or anomie. Honestly, it was a real game changer for sociological methodology. So what's the big takeaway from all this? It's that all science, whether it's physics measuring the atomic weight of some element or sociology analyzing the intricate role sets of an Indian community, is an ongoing, living process. Science grows incredibly fast, and conclusions are basically always provisional. A theory is, at its core, a revisable proposition. When new historical evidence or fresh data emerges, the theory simply has to adapt. And really, that is the true, beautiful method of science. And that wraps up our explainer for today. We've climbed a ladder all the way from a simple packet of salt in a Naga Valley straight up to the complex sociological theories of Durkheim, Weber, and Merton. Now, I want to leave you with a question to really chew on. When you look at your own life, the dyads you form, and the multiple different roles you play every single day, what is the balance of consequences in your immediate society? How do the structures around you function, or perhaps dysfunction? Thank you so much for learning with me today. Keep asking those big questions, keep looking at the structure of things around you, and I will see you in the next explainer.